In a world where rules define everything, some substances dare to be different. Today we're exploring materials that toss the textbook out the window. They're nature's own rebels, defying logic and bending the laws of physics. So, prepare to be amazed as we uncover the secrets of these strange substances that refuse to follow nature's rules. Before we get started, please make sure to like the video and subscribe to our channel if you haven't done so yet. Number 1. The liquid that climbs, non-Newtonian fluids. Non-Newtonian fluids are among the most unusual substances you can come across. Unlike water or oil, these fluids have a unique feature. They change how they move depending on the force applied to them. One moment, they act like a typical liquid, flowing gently when poured. The next moment, they behave more like a solid, especially when hit or shaken quickly. A common example of a non-Newtonian fluid is a mixture of corn, starch, and water. When you press on this mixture slowly, your hand sinks in as if it were a liquid. But if you punch it quickly, it becomes hard and your hand bounces off. This weird behavior is due to the way the particles in the fluid interact. When moved gently, they slide past each other smoothly. But under sudden force, they lock together, creating a solid-like state. This unique property allows for some fascinating experiments and applications. For instance, people have filled pools with this mixture, allowing them to run across the surface without sinking. If they stop or move too slowly, they start to sink, as the fluid turns back into a liquid state. Non-Newtonian fluids don't just provide fun and games, they have practical uses too. Some companies use these fluids in protective gear, like knee pads or bike helmets. The fluid remains soft and flexible under normal conditions, providing comfort. But upon impact, it hardens instantly, offering protection. Number 2. Reverse. Melting. The peculiar case of gallium. Gallium is a metal that doesn't play by the rules we know. When you think of metals, you probably think of strong, solid materials. But gallium is different. It's a soft metal, so soft that you can cut it with a knife. What's truly strange about gallium is how it behaves with temperature changes. Normally, when you heat a solid, it melts into a liquid. That's what happens with ice turning into water. But gallium does the opposite. It's solid at room temperature, and when you hold it in your hand, your body heat is enough to melt it. It turns into a liquid right in your palm. Now here's where it gets even weirder. When you start heating this liquid gallium, instead of staying liquid or turning into a gas, it begins to solidify once it reaches a certain temperature. This goes against everything we usually see with other materials. This bizarre behavior has a lot to do with the structure of gallium atoms and how they interact with each other. When the temperature rises, these atoms rearrange in a way that makes the material solidify. This is not just a quirky party trick. It has real-world applications. Gallium is used in thermometers, in some electronic devices, and even in medical applications because of this unique property. Gallium, with its reverse melting, is one such surprise, defying the norms and showing that even in science, exceptions always exist. Number 3. Aerogel, the ghostly material. Aerogel is a substance that looks like a trick from a magician's handbook, but is very much real and grounded in science. What makes aerogel stand out is its unbelievable lightness. It's so light that if you held a piece in your hand, you might not even feel it. Despite this, it can hold up to thousands of times its own weight. This remarkable strength-to-weight ratio makes it a marvel in material science. The creation of aerogel is a tale of human ingenuity. It starts with a gel similar to the jellies we're familiar with, but then the liquid part of the gel is replaced with gas. This process, known as supercritical drying, leaves behind a material with up to 99.8% air. It's this airiness that gives aerogel its ghostly, translucent appearance and its nickname, frozen smoke. But aerogel isn't just a wonder to look at. Its practical uses are vast and impressive. One of its most important applications is in insulation. Aerogel is an outstanding insulator, used in everything from spacesuits to skylights, keeping astronauts safe from extreme temperatures and homes warm during winters. Another fascinating aspect of aerogel is its environmental applications. It can absorb pollutants, making it a potential ally in cleaning up spills and environmental hazards. Its ability to capture more than its weight in harmful materials could be a game changer in environmental protection efforts. Number 4. Quantum levitation. Quantum levitation is a mind-boggling aspect of physics where materials seem to defy gravity, floating in mid-air as if by magic. This phenomenon is based on the principles of superconductivity and magnetic fields. When certain materials are cooled to extremely low temperatures, they enter a superconductive state. In this state, they exhibit remarkable properties, one of which is the ability to levitate over a magnetic source. This fascinating effect occurs due to the locking of the material in a magnetic field, a process known as the Meissner effect. In simpler terms, the superconductive material and the magnetic field interact in a way that the material is locked in space above the magnet. What's astonishing is that the levitating object maintains its position even when the magnet is moved. It can stay hovering in mid-air, seemingly unaffected by gravity. Researchers have been captivated by quantum levitation because it's not just a stunning visual display, but it also has practical applications. For example, it's being explored for use in frictionless transportation systems. Imagine trains that float above their tracks, reducing wear and tear and allowing for incredibly smooth and efficient travel. However, the challenge lies in the requirement for extremely cold temperatures to achieve superconductivity. Most materials need to be cooled with liquid nitrogen, which limits practical applications outside of controlled environments. Scientists are continually searching for materials that become superconductive at higher temperatures, which would make this technology more feasible for everyday uses. Number 5. The disappearing act, vanishing materials. These aren't your typical materials. They have a unique ability to almost completely disappear from sight. This isn't magic, but rather a clever use of science. One of the most fascinating examples is vantablack. This substance is known as one of the darkest materials ever created. It's made up of tiny carbon nanotubes. When light hits vantablack, it gets trapped instead of bouncing back to our eyes. This makes it look like a void, as if the object covered in vantablack has vanished. It's so effective that it hides all the details of the object's surface. Another interesting material is transparent aluminum. This isn't the aluminum used in soda cans, but a new kind of ceramic. It's transparent like glass but strong like metal. It can protect like a thick, heavy piece of metal, but you can see right through it. This material could change how we make everything from windows to electronics. Then there's the angle-sensitive pigment. This pigment changes color or vanishes depending on your viewing angle. Painted on an object, it can make parts of it disappear and reappear as you move around it. It's like a chameleon, blending into its surroundings. These materials aren't just cool tricks, they have serious uses. Vantablack can help in space exploration by reducing stray light in telescopes. Transparent aluminum can be used in making strong yet see-through protective gear. Angle-sensitive pigments can improve camouflage technology. Number 6. Memory metals, the shapeshifters. Welcome to the intriguing world of memory metals, a group of materials that seem to have a mind of their own. These metals have a unique ability to return to their original shape after being bent, twisted, or even smashed. It's not magic, but a remarkable characteristic of their atomic structure. The journey of these metals begins with a change in shape. When you bend or twist them, they hold the new shape as if they've forgotten their original form. But here's where the magic happens. Heat them slightly, and they spring back to their initial shape, as if they remember their original form. This phenomenon known as the shape memory effect, isn't just a cool party trick. It has practical applications in various fields. In medicine, these metals are a game changer. Imagine small medical devices like stents or braces that are compacted for easy insertion into the body and then expand to their desired shape inside. This capability makes surgeries less invasive and recovery times shorter. The aerospace industry also benefits from memory metals. Parts made from these materials can withstand the harsh conditions of space travel. If a component warps or bends, it can be returned to its original shape with just a bit of heat. This self-repairing ability reduces the need for complex maintenance procedures in space. These metals aren't just limited to high-tech fields. They are creeping into everyday life. Glasses with memory metal frames can be twisted or bent, and they'll just bounce back to their original shape. It's easy to see why these metals are named shapeshifters. They challenge our understanding of how metals behave, opening up new possibilities in technology and design. Number 7. Superfluids, the flow without friction. Superfluids are one of nature's most remarkable creations, showcasing fluid movement without any friction. These fluids can flow endlessly without losing any energy, a concept that seems almost magical. The secret behind this extraordinary ability lies in the realm of extreme cold. When certain liquids, like helium, are cooled to incredibly low temperatures, near absolute zero, they undergo a transformation that defies common understanding of how fluids behave. In this supercooled state, superfluids can perform astonishing feats. For example, they can flow through incredibly tiny spaces, much smaller than any other liquid can manage. This ability is not just a curious phenomenon, but has practical implications. Scientists are exploring how this frictionless flow can be harnessed for highly sensitive measuring instruments and in other areas of technology. Another intriguing aspect of superfluids is their ability to climb walls. It sounds impossible, but in the superfluid state, these liquids can actually crawl up and over the sides of a container, defying gravity in a way that no other liquid can. This behavior is a direct result of their frictionless nature, allowing them to move in ways that seem to contradict the basic principles of physics. Nature is filled with wonders that challenge our understanding and inspire innovation. If you enjoyed this mysterious, unknown journey into the world of nature's rule breakers, remember to like and subscribe.